So let me see how to do this. You guys try sending me a text. I think I've made it so everybody's. Let's see here. Yeah, I think you guys have permission. So go ahead and send me a text message, say hi. Okay, good. So what we're gonna do first thing is we're going to use the washer method for this problem that we did the other day. We're going to rotate around, instead of rotating around the x-axis, we're going to rotate around the y-axis. So just going to get this thing out of here. So what we would do is, instead of the rectangle being vertical, it would be horizontal like this. And we would rotate around the y-axis. Then you have to look at what the radiuses are. So you always look at the distance from the axis of rotation to the inner curve and from the axis of rotation to the outer curve. So in the case of r of y, this is my inside radius, and that's my outside radius. This would be my y limit, lower y limit, and this would be my upper y limit. So just like we did before, if you're integrating with respect to y, well, first the equation for the volume of a washer or a solid using the washer method is pi times the integral from c to d of capital R of y squared minus small r of y squared, the whole thing times dy. So the original equation was y equals x. Well, the appropriate function the other way around is you solve for x. F of y is x, just like f of x is y. And so f of y equals y. Since over here f of x equals x. Okay, so that's the equation for the inner radius. So that's also equal to small r of y. And then capital R of y is just y. Actually, it's x equals 5. So r of y is just like we're saying x is equal to something. Here x is equal to y, here x is equal to 5. So that's the outside radius. Our lower limit of integration, c, is 2, y equals 2, and the upper limit of integration is d, which is y equals 5. That's right there. So here's the y limits. And so to calculate the volume, it's going to be pi times the integral from 2 to 5 of capital R of y, which is 5, square that, and then subtract small r of y, which is y, and we square that, and then we multiply by dy. Now let's compare that with what we had when we did it the other direction. So this was, let me copy that over. For some reason it won't copy, so I'm just having to drag it over. So that was the equation around the x-axis. When we went around the x-axis, the outside radius was the diagonal curve, and the inside radius was y equals 2. The limits were from x equals 2 to x equals 5. Whereas when we rotate around the y-axis, the inside radius was the diagonal curve, and the outside radius was just a straight line. The limits were from 2 to 5. Again, that's just because the line is a y equals x, so it's the same. If it was something like y equals 2x, then these limits would be different, but it's just because the symmetric nature of the function y equals x, or x equals y. And you can evaluate those integrals. We're not actually going to do it. Okay, so we're going to move on, and we're going to look at this problem, which is problem 13 in your book. And we're going to do the same thing. We're actually going to do one more thing, which is first thing, we're going to rotate around the x-axis, meaning the line y equals 0. We're also going to rotate around the line y equals 6, which we haven't done yet. So let's do the first one, and we will calculate this one. So we draw our representative rectangle inside, which is a vertical rectangle because we're using the washer around the x-axis. And if we draw go from the x-axis to the first curve we meet, which is the red curve, that's going to be our inside radius. And if we keep going, we'll get to the blue curve, which is the outside radius. So one side of the rectangle is on the inside of the radius, one's on the outside radius. So since the functions are defined in terms of y, we're in good shape. So again, for the washer method, and we have to use the washer method because the inside radius, it's not the x-axis. So we have like a hole. We're going to have a hole in the center. So we use the washer method. So we'll say washer method and horizontal axis. So the formula for that is that the volume is equal to pi times the integral from a to b of capital R of x, which is the outside radius, squared, minus small r of x, which is the inside radius, squared, all times dx. So we just have to figure out the four things. So let's look at the limits. So you can see the functions intersect these 2 points at x equals 0. And if we go over here, you can see that the other point of intersection is x equals 2. Now, we could do that analytically by setting these equal to each other. But we can see it off the graph, so I'm just going to say a is 0, b is equal to 2. That's the x limits on this thing. The outside radius is the blue curve, which is the second one up here, 4x minus x squared. And the inside radius is the red curve, which is that one. So all we do now is just plug her in there and do the calculation. So we have 4x minus x squared minus small r of x squared all times dx, and I forgot to put the limits in. So that's 0 and 2. Okay, so let's see how you guys, who's here today. Caleb, Kinsey. I thought Andrew, I was surprised Andrew asked me where the class was. Surprised he hadn't shown up yet. Let me make sure I'm recording. Yep. Okay, is everybody okay with what we've done so far? All you have to do is you go up to you can go up to the emoticon on your interface, and you can give me a approval or a disapproval. So if you give me a thumbs up or a thumbs down if you understand what's going on. So it's above the chat window, the little smiley face, and then just pick one of the, you can pick confusion, approval, disapproval. Okay, so Caleb's got his happy face, good. How about the rest of you guys? Tyler says thumbs up, Caleb says football. Hopefully you other guys you see it, you just haven't. Okay, moving on. Oh, good. Kenzie's found it. Okay, so let's go ahead. Well, actually, why don't you all work on that? See if you can come up with an answer. And what I'm going to do is I'm going to let's try to figure out. Yeah, just work on it on your own. I'll give you a few minutes to get started, and then I'll start working on it. And then if you get stuck, you can go back. But what you need to do is just multiply this out using FOIL, and then combine the like terms, and then integrate. You probably have 3 terms to integrate, maybe 2, because the x squared, x to the 4ths might cancel out. I'm not sure. So it's just a polynomial integration, but you got to multiply everything out so you just have a simple polynomial. Okay, so I'm going to start working slowly so I don't pass you guys up. That way I make sure I don't make any mistakes. Oh, there's Andrew. So the x to the 4ths do cancel out. It's just a 2-term polynomial integration. And I'm just going to check something here. Okay, we're back. Okay, so there's my answer. Let's see if you guys got the same answer. So I've got, so go ahead and enter a little chat window and say, yeah, that's what I got. Same, you're wrong. Nope. Anybody get what I got? No? Uh-oh. Where do you see where I made my mistake? You had 32 over 3 times pi. That's what I got. Okay, Amelia got the same thing. Yay. So we're both wrong. Oh, Andrew got, okay, so we got 2 people. So I'm not sure, you might go back and look, see where you made, let me just explain it and see if you found out where your mistake was. Okay, Caleb knows where he went wrong. Okay, so yeah, we multiplied this term out. So what I did was I said 4x times 4x is 16x squared, and then you multiply 4x times negative x squared, and you get negative 4x cubed, and there's 2 of those, so you get negative 8x cubed, and then negative x squared times negative x squared is positive x to the 4th. You get negative the quantity x squared, which is x to the 4th. Those cancel out. You integrate, add 1 to the exponent, divide by the new exponent. The 0, those go to 0. And then you plug in 2, so we have 16 times 8, and 8 times 16, which turns out to be 64, or 128. 16 times 8 is 128. This is 128. So I factored out the 128, and I had a 3rd minus a 4th, which is a 12th. So you get 128 pi over 12, which can be divisible by 4, and you get 32 over 3 pi. Okay. Let's just look what this thing looks like. So I'm going to open up the SketchUp. So it's kind of what it looks like. So let me share SketchUp with you. Of course, it's not going to be as seamless as you see in class. Okay, so what I have is this curve. This represents the y equals x squared, and this represents 4x minus x squared. So it's a 2-dimensional surface in the x and y plane. And all we're doing is the red axis is the x-axis. So we're going to rotate around the x-axis. And this little sliver here is supposed to represent a rectangle. So if I take that sliver and I rotate around the x-axis, I get that. So you can see it looks like a washer. It's got a hole in the middle. And the basic idea is you just take you take adjacent washers and you put them all together and you let the washer width go to 0. That's what the integration is. And if you finally, so what we're going to do is we're going to just do the rest of the shape so you can see what it looks like. So that's what it looks like. So this top surface is the outside radius, and this curve here, this one that goes like that, that's y equals x squared. This is y equals 4x minus x squared, and the space between those is the volume that we're looking at. And you know, it doesn't have a hole that goes all the way through right here because the 2 points meet. The thickness of this shell would be essentially 0 right there, except it's 0 at and in 1 point, so you don't really see it. But it does have a concave nature to it. Okay. So the next thing we're going to do is, what if I rotate around, instead of y equals 0, which is the x-axis, if I rotate around a line y equals 6. So what that's going to do, so this is the figure that goes along with it. And so this is the line y equals 6. And these are the two curves. Now, what this line represents is the distance from the axis of rotation to the nearest curve, which in this case turns out to be the blue curve. And the distance from the axis of rotation to the outside radius is, that's capital R of x. So the R of x is switched because I'm coming from a different direction. So what are the values of those radii in terms of the function? Because the function is in terms of x. So it's the distance from the x-axis. But what we want to do is we want to get the distance from this other axis, this horizontal line y equals 6. So the way it works is you take the value of the line that you're rotating around, other than x equals 0, and you subtract the value of the function. Now, why does that work? Because the distance from the x-axis to, say, the blue curve is 4x minus x squared. And if the total distance from the red line to the x-axis is 6, the distance from here to the blue line is going to be 6 minus the distance from the x-axis to here. So it's just saying the total distance is 6. And if this distance is the function, then this distance is 6 minus the function. So the inside radius of this rotation is the blue curve. So we take 6 minus 4x minus x squared. And the outside radius, which is the red curve, is going to be 6 minus the red function's value, minus x squared. So those are my radii, and everything else stays the same. So if we want to calculate the volume of that as it rotates around y equals 6, we would again use the formula for the volume. And the reason they talk about a horizontal axis is so you're not limited to the x-axis. So you always have to think about the r's are the distances from the axis of rotation, not necessarily from the x-axis. So we integrate from 0 to 2. The outside radius is going to be 6 minus x squared, and we square that, and we subtract 6 minus the quantity 4x minus x squared, the whole thing squared, and multiply by dx. So you can see this calculation is going to be a little more difficult. So what we have is we actually have a quadratic equation here that we have to square. So the question is, how do you do that? This part's going to be easy. That's going to be 36 minus 12x squared plus x to the fourth. Okay, because you square this, you take 6 minus negative 6x squared, which is negative 6x squared, and you double that. So you get negative 12x squared. And then you take negative x squared times negative x squared gives you positive x to the fourth. So the question is, what's the easiest way to do that? We don't do that often. And basically what we have is if we take away the parentheses, we have 6 minus 4x plus x squared, the whole thing squared, which is 6 minus 4x plus x squared times 6 minus 4x plus x squared. So one way would be just to take this number times each one of those, this times each one of those, and this times each one of those, and then you'd have you'd have 9 terms, and then you'd combine the like terms and simplify. Another way you can do it is kind of a modified multiplication here. So what we do is, it's basically the same thing. It's just a way of keeping track of the like terms easier. So what you would have is, well, actually you are doing the same thing. It's just you're doing it in a column format. So here I would have x to the 4th. So I'm going to take x squared and multiply each one of these. So I get x to the 4th minus 4x cubed. So take x squared times negative 4x. And then I have 6 times x squared. So I get 6x squared. And then I go to the next number, and I'm going to put the first entry in this column. So you get negative 4x times x squared, which is negative 4x cubed. And then you get these two multiplied together, which is going to be positive 16x squared. And then 6 times negative 4x, which gives me negative 24x. And then finally this, so I'll get 6x squared, 6 times that, and 6 times that, which is negative 24x. And then I'll get 36. And then you just add all these together. So you get x to the 4th minus 8x cubed, and you get 28x squared minus 48x and 36. I probably should have done it the other way around. But actually these are the other way. So now what you would do is you would take this and add it to that, or subtract it. So what's going to happen is these two terms are going to cancel out when I subtract it. And this is not going to cancel out. This one will cancel out with that one. And the negative 12x squared, so what I'm doing here is I'm basically subtracting this whole thing. So what we're left with, so our integration is going to be pi times the integral from 0 to 2. So I'll get a negative times a negative, so I get 48x. I have negative 12x squared minus 28x, so that's minus 40x squared. And then I have a negative times a negative, so it's positive, so plus 8x cubed, the whole thing times dx. So, it's instead of 2 terms, it's 3 terms, ultimately. It's just the simplification that you got to be careful about. Okay, so I'm going to let you tell me if I did that right. So what do you think? Do you believe it? That's what you got. Okay, good. How about you, Kenzie? Okay, so we're in good shape. So now all we have to do is just integrate that. So I'm going to let you go ahead, and I'll give you a couple minutes start and see if you can come up with the answer. I think I'm gonna fix myself a cup of coffee. Use my Keurig here. here is my coffee. Okay, so how about the answer there? Yes. Okay. So that's it's a little, sometimes it's tricky, a little tricky to visualize what's going on. What I'm going to do is, I think I have a link here. Here's my SketchUp example. And let me close the other one, and I'll open that up for you, just so you can see what this thing looks like. Here it goes, filling up with hot water. Okay, so here's the drawing. So here's it's the same area. Here's the same rectangle. This circle here is at y equals 6. So instead of rotating around the x-axis, I'm rotating around this axis. And because the distance, you can see the distance from here to the x-axis is smaller than the distance from here to this axis. So we'd expect the volume to be bigger, which it was. It was actually twice as big. So what we'll do is we'll draw the rectangle first, show you that it is a washer. And so click on that, and you zoom out a little bit. So there you go. There's your washer rotating around this point right there. And then we can do the rest of it. So we'll do this part, this side first. And we'll do the next. Well, I'll probably have to click on that and rotate around so I can see that other part. So there you go. That's what it looks like. I mean, it kind of looks like the same kind of basic shape, except it's bigger. You've got a convex side here and a concave, sort of a concave side. That is, I don't know if it's concave, but anyway, that's what the three-dimensional shape looks like. And what we're doing is calculating the volume by finding the area, the volume of washers that rotate around there, and then we're stacking the washers in the x direction. So we're integrating, and we're letting the number of rectangles go to infinity, and the width of the rectangles go to 0, and we get the exact answer. Okay, so that was that part. Now we're going to do the same two curves, but we're going to rotate around the y-axis. So what we've got to do is we have to take those two equations and we have to write them as a function of y instead of as a function of x. Also, when we rotated around the x-axis, the red curve was the inside radius and the blue curve was the outside radius. If we rotate around the y-axis, the inside radius is the blue curve and the outside radius is the red curve. Our limits are not from 0 to 2, because that's the x limits. They go from 0 to 4. So the first thing you have to do when you have something like this is you have to take the two functions and rewrite them. So the red curve was y equals x squared. So if we solve for x, it's going to be x is equal to the plus or minus the square root of y. Now the question is, which one of these is it? So I'm going to ask you to think about this. Is the blue curve that we're interested in, which is the blue curve from here to here, is that actually the red curve, sorry. The red curve from here to here, is that plus or minus the square root? So the answer is put it in the window, put a plus or a minus. So Amelia says plus. Let's see what everybody else says. Yep, plus. Anybody else? Equals. That wasn't a choice, Andrew. Okay, Kenzie's going to put in. Okay, so we're all saying plus basically, and that's true. It's true because this one would be negative the square root, and this would be positive the square root, because this is a positive x value, and this is a negative x value. Okay, so we're going to choose to use, in this case, positive the square root of y as the function. The second one was y equals 4x minus x squared. So to solve for y, we'd have to use completing the square. So what I would do is I'd factor out a negative sign, just because I can't handle factoring things with a negative coefficient on x squared. And so you would take negative 4, divide by 2, square it, which would be positive 4. So we add 4 there. And since we're adding 4 here, we're really subtracting 4 from the equation. So if we're subtracting 4, we have to add 4 back in. So if we multiplied this thing out, you'd get negative x squared, positive x to the 4th, negative 4, and then plus 4, and the negative 4 and the plus 4 would cancel out. So we know that's correct. Then you collapse this down to x minus 2 quantity squared. Then we would subtract 4 from both sides. What do we do next? So see, we're right near the end of this section. We would multiply by negative 1. So I'm just going to change the order of those. So we'd have x minus 2 squared. And take the square root. So we get plus or minus the square root of 4 minus y is equal to x minus 2. And then we would add 2. So you add 2, you get 2 plus or minus the square root of 4 minus y. So again, the question is, should I use plus the square root or minus the square root? And we'll go back to the graph. So we're looking at the blue curve. We want this part of the blue curve. So would that be minus the square root or plus the square root? So that's time for you to put an answer in, plus or minus. So you guys are thinking about it, huh? So here's 2, and if you go to the right, you would think it would be something, and if you go to the left, you would think it's something else. Okay, so it's negative because this is on the positive side and this is on the negative side. So the answer is negative. So we would use x equals 2 minus the square root of 4 minus y. And you have to think about what, functions. If something's a function of y, you can't have it intersect twice. So, we'd have 2 functions. We'd have this function and we'd have this function. This whole thing would not be a function as a function of y. But it's okay because we're only worried about one part of it. Okay, so now that we have all that stuff, what would be the equation? Volume equals pi times the integral for c to d of r of y squared minus small r of y squared dy. So we should be able to plug everything in now. We'll have to go back and look at the figure and remember what the limits are. So let's go back here. So the limits were from 0, y equals 0 to y equals 4. The inside curve is this one. So you'd have 2 minus the square root of 4 minus y squared. Oh, well, that's actually the inside radius. That's wrong. Yeah, let's go back to the drawing since I confused you here. The blue curve is the inside radius, so we're going to subtract that. The red curve is the outside radius. So we're actually going to use the red curve, which was this one right here. And we use plus the square root. So it's going to be the square root of y squared minus 2 minus the square root of 4 minus y quantity squared, the whole thing times dy. So that, it looks more complicated. It's not super complicated because you're going to, when you multiply everything out, some things are going to cancel out. Some of the square roots are going to become just y. I think let's see how much time we got. We've got 14 minutes. So first, before we get started, we might not get completely done with that. Actually, I think I'm going to wait till tomorrow when we're in class to actually work through that. So let's go back. Here we go. Sketch up. Let's look at how this thing looks like in SketchUp. I'll share it with you in a second. Okay, I'm ready to share it with you. So here's the area again. In this case, I don't have my rectangle yet. So what I would do is I would take my pencil and I would draw a horizontal line to the other side, like there, and then I take another one like that, and I go to the other side. And I have to make sure it's horizontal, which doesn't want to be horizontal, but there we go. So what I've done is I've created a rectangle. That's a horizontal rectangle instead of vertical rectangle. And I'm going to rotate that around the y-axis. So I've got my circle here to follow. So I'll click the circle. I'll go to Tools, Follow Me, click on that, and there you go. So it's a washer again. The center is the y-axis. And then what I would do is I would just stack those rectangles on top of those washers on top of each other. And so what the thing ultimately looks like is that. It kind of looks like a missile or something with a place to put your drink. So that's the shape. And again, what we've done is we have calculated the volume of that shape. So there's the homework problems from this section. And what we're going to do now is we'll come back and finish this integral tomorrow. Hopefully, actually, what I'm going to ask you to do is to give that a try and turn it in first thing in the morning. And so if anybody watches this recording later, they can do that and turn that in. And if you didn't watch the recording, then you're not going to get credit for that. So that'll be a test to see. So don't call anybody and tell them they need to watch the recording. Let them figure it out themselves. But so what we're looking at is for tomorrow, if you can do that integration. And we'll just stop now, so you'll have 10 minutes here. You should be able to finish in about 10 minutes. See what kind of number you get as far as the value. And you can turn that in for a homework grade. So anybody have any questions at all? So I came in about 20 till 9, I think it was, and the water was on. So I'm not sure. Hopefully they fixed what they needed to fix, but it was probably done by 8 o'clock. Participation grade, yes. I'm not guaranteeing. Well, yeah. If you attempt it, you will get credit. If you don't get it right, that's not a problem. Just give your best shot. But that means that you came to class or you watched the recording. If you decided to just skip the whole thing, then there's a penalty to pay. So thank you all. That's why you guys get A's, because you come. So we'll see you tomorrow. So what you do, you guys who haven't been on before, what you do is you go up to File, and then you go to Exit, and that's the way you log yourself off.